Welcome to Year 1 Mechanics, Chapter 10.6 about pulleys. In Chapter 10.5, in the last lesson, we were looking into connected particles, maybe like a van towing a caravan or a woman in a lift. Well, they're considered as connected particle because they are moving in the same direction. Now, pulleys is also a connected particle, a part of it. However, it's not the same as the previous one because now in a pulley system, you can imagine if one pulls down, the other goes up. So it's like in traveling opposite direction. Um, so in this lesson, you'll be introduced to different calculations of pulleys, some basic calculation of pulleys. When I say basic, it's actually a lot of students will find it quite tricky. But then in year two mechanics, where you'll be applying pulley into different scenarios, maybe on an incline plane, maybe on a cliff or something. So yeah, let's go into it. So a pulley is a system, it's a wheel, which a cord, a string, a rope, a cable, whatever we call it, we usually call it a string, okay, passes over. So first question here is, okay, why can't we just model both particles as single particle as before? The reason is quite simple, because the particles, as I said, are moving in opposite direction. So the tensions do not cancel out each other. Okay, so if you think about one is moving up and the other one, so one is moving down and the other is going up, there you can see they're moving opposite direction. Um, Under what condition is tension in each part of the tension, the strain, the same? Now you'd be thinking, okay, here's a string. Okay, so where is the tension acting? Well, what we know is the tension will always, for the mass, will always be acting towards the pulley. Okay, so because you can think about, even though you're moving down or moving up, the mass is still being dangled by these strings. So these strings are still holding the mass up, even though the mass is dropping. However, the tension is still holding up because you can imagine it's the string, lifting the mass down slowly. So it's still a controlling force upwards. But under what condition are these two equal? Well, these two are equal. Okay, that's the assumption that we make in the mechanics in A-level maths, which is when the string, okay, is modeled as light and inextensible. You will see that in actually just in the line below in here, a light inextensible string, you can see is a common assumption that we make in mechanics in A-level maths. Inextensible, because any force applied to one end of the string is transmitted equally throughout, its length. So resulting in a constant tension. So we use a T, a value across the string. So that's the reason why. Okay, so you can imagine because it's inextensible. Inextensible. What it means is if one travels a certain distance, a certain speed, whatever, the other mass will be traveling up the same speed because they're in sync. Therefore, the tension value will be the same across the whole string. Also, is a light string. Light string means the string has no mass. Okay, right. Let's have a look of the example below in here. Let me put it. Right, particles P and Q of mass 2m and 3m are attached to the ends of a light inextensible string. The string passes over a small, smooth, fixed pulley, and the masses hang with the string taut. Now, if you don't know what the word taut means tightened. Tightened. That means it's not loose. Okay, the system is released from rest. Write an equation for the motion of P and Q. So let's try to draw the motion. Let's try to draw a diagram for this question. Okay, so we can draw a pulley. Okay, you don't have to write a pulley in there. Okay, so that's a pulley. And then you've got the mass in here. Okay, that's P. And then we have Q in here. Okay, first of all, we know there's tension. Okay, so tension we're putting up. Okay, pointing towards the pulley. Now, what else? What about the weight? We always have the weight, remember? So the weight is acting vertically downwards. So P is 2m. Therefore, the weight will be 2mg. The Q will be 3mg. Now you have to be careful. Sometimes they give you the weight rather than the masses. They told you the mass, therefore the weight will be 2mg. If they give you the weight, then you don't have to add the g. All right. So when you release the system, you can imagine what will happen. Well, the Q will drop simply because Q is heavier and P will go up. Okay. Right. So write an equation for the motion of motion for P and for Q. So let's look at P. Okay. Let's look at P. So P, we are moving up. So F equals ma. We're going upwards. So if we're going upwards, the resultant force will be the upward force, T, take away downward force, 2mg equals the mass of P, 2m times A. Okay. So I did go through a few things in here. Do you want to write it down? Okay. So first of all, in here, you write down why is the force T minus 2mg rather than 2mg minus T? It's T minus 2mg because we're going up. So going up means upward force, take away downward force. Okay, right, so I'm not going to explain much in here. So what I'm also going to do is I'm going to sub in 9.8. So T minus 2 times 9.8 is 19.6 m equals 2 ma. And for Q, we'll do the same thing. F equals ma, but this time is downwards because Q is going downwards. So therefore, the resultant force will be 3mg minus T. As we're going down, the downward force has to be bigger than upward force. So 3mg minus T equals the mass 3ma. 3g is 29.4 m minus T equals 3ma. So that's the answer to part A. Okay, so we've got the two equations, right? Part B, find acceleration for each mass. Well, to find acceleration, you can see we've got two equations here, and there are two unknowns. Well, are there not three, m, t, and a? Yes, but because the m will cancel out each other. So how do well, let's try to solve the equation. I will make t the subject in here. So I'll make t the subject. So t equals 2ma plus 19.6 m. And then in here, to make t the subject, I can do 29.4 m minus 3 ma equals t. So let me flip the left and the right hand side. Minus 3 ma. So that we can have a simultaneous equation. Okay, so simultaneous equation. So 2ma plus 19.6 m equals 29.4 m minus 3ma. What I told you, what did I say? M will cancel out because you can see there's m across the whole equation. So let me rewrite that. So 2a plus 19.6 equals 29.4 minus 3a. Make a the subject, so 5a equals, bring it over 9.8 divided by 5. I believe you should get 1.4 if I'm not mistaken. Nope, 1.96. So don't trust your mental maths. So a equals 1.96, right? And then part C, the question wants us to find the tension. So once we found A, so we can sub in the equation to find tension. Quite simple. So let's find a tension. So to find tension, let's sub in one of those. So T equals 2ma plus 19.6 m. So T equals 2m times 1.96 plus 19.6 m, which will be in terms of m. So T will equal to 2 times 1.96 plus 19.6 is 23.52. So 23.52 m newtons. Okay, and that's the answer. I know so the question say will be in terms of m. That's how we know it will be. Yeah, so that's how we can do it. Part D, find the force exerted on the pulley by the string. Now, find the force exerted on the pulley by the string. So you'd be thinking, okay, what force are the string applying to the pulley? Well, now so far we've been looking at the perspective of the masses of P and Q, right? For P, yes, the string is holding up mid-air, so it's Q, so therefore tension pointing up. However, if we look at the perspective of the pulley, okay, so let's look at the perspective of the pulley. So the perspective of pulley. So here's the pulley, okay? Here's the P and here's Q, right? So if we look at the pulley. Now, pulley is actually quite sad. The reason being is, now imagine you are the pulley, okay? And the string is like your hair, right? What happens if someone attach a weight into the end of your hair? You will feel your hair being dragged downwards, right? So for the pulley, the tension will be downwards. Now you might be asking, so why don't you put tension? Why don't you put the two T's in here as well? The two green T's, pun intended, the color. The green T's in here, The reason being is I don't want to confuse students with these two t's. When we do normal calculation, we always consider just these two t's. But when it comes to force exerted on the pulley by the string, when we talk about the force exerted on the pulley, so we're going to look into the perspective pulley, then we look in these two t's. Normally, when we do the calculation, we ignore these two t's. So I don't want to confuse students. Yes, technically they are there. Okay, they are there, but I'm not putting in there. So if you really want to put it inside, you can put on the original in here. Okay, so you can put these two t's in here. Okay, but normally we don't write these two t's putting downwards because these two t's are mainly for the pulley, but rarely we look in the perspective of pulley. Normally when we calculate the acceleration, tension, whatever, it's always from the perspective of the masses rather than pulley. So, but this question, perspective of pulley is that way. So, therefore, force exerted. So force exerted, I can't spell, exerted on the pulley equals to, so you can see it's basically t plus t because they're both pointing downwards. So which is 2t, which is 2 times 23.52 m, which is times by 2, which is 47.04 m Newton. That means the pulley has to withstand 47.04 m of newtons of weight of force being dragged down. Okay. Yeah. Okay. So the force exerted on pulley is just 2t because these just drag it down. So t plus t. Part E. Find the distance moved by Q in the first 4 seconds, assuming that P does not reach the pulley. So distance, you can see distance, time, keyword is Sievert. All right. So Sievert. So question E, Sievert. Find distance, want to find displacement. We know time is 4. Acceleration we'll work out, which is 1.96. Okay. Um, what about, we need 3 pieces of information. We're lacking of 1. We need either U or V. So let's really question. The system is released from rest, right? So release from rest means U is 0. So U equals 0. You can say released from rest. So hopefully, okay, can you recall which formula we need to use? I'll give you 3 seconds to think about. Just kidding. S equals ut plus a half at squared. So S equals 0 plus a half times 1.96 times 4 squared. Okay, so S equals, so put in calculator, 0.5 times 1.96 times 4 squared, which is 15.68 meters. Okay, so that's the answer. That's the answer, right? If you're happy with this, okay, your turn to have a go at the question. So I will draw your diagram if you need to, if you want it. Okay, but if you don't, you can pause the video and have a go at all the questions. It's very similar to our previous one. Okay, pause the video, have a go at the question. When you're ready for the answer, you can press play. Meanwhile, I'm going to draw the pulley. Right, here are the answers. Okay, you got it right. Well done. You've got all of them right. Well done. Move on to the next one. Okay, but if you don't, let's go for it. First of all, let's put in the forces in there. So first of all, we've got tension pointing towards the pulley. We also have the weight. So mass A is the mass of A is 4 kilograms, so it'll be 4g, and B will be 3g. Now, what you have to understand is A this time will be dropping, and B will be lifted up. Okay, because A is heavier. All right, so find the tension of a string. So we have separate equation of A and B. So let's set the equation for A. So for A, we use F equals MA going down. Now, if you're struggling to start a question and now you sort of, now I know I think how to do it, please pause the video, at any time that you feel like you are able to try the question. The main thing is you try it yourself first before listening to it. That is the best way of learning. So whether it's right or wrong, because wrong, you will need to understand, okay, why is it wrong? But if it's correct, then you don't have to listen, waste time and listen to me. So the force is 4g minus t, because going downwards, that means downward force must be bigger than upward force. So 4g minus t equals m4a. And 4 times 9.8 is, if you remember what I said, I don't like writing a g in there because students often mistake, mistake this as the variable. So there's actually no variable. So 39.2 minus t equals 4a. Make t a subject, so t equals 39.2 minus 4a. A lot of students will make mistake in the plus and minus sign in here when you rearrange it, so be careful with it. So part B, particle B is moving up, so t minus 3g equals 3a. So t 3 times 9.8 is 29.4, is it? 29.4 equals 3a. So t equals 3a plus 29.4. I see a simultaneous equation, so I'm going to make them equal. 39.2 minus 4a equals 3a plus 29.4. Bring the 4a over the right-hand side, 7a, and this one will be 9.8. Divided by 7, a is 1.4 meter per second squared. So this is part B. Why do you work out the answer for part B before part A? Now in mechanics, your answer usually is marked as a whole rather than by parts. So don't worry about answering part B before part A. This actually happens quite common. So you won't be given marks just based on part A, part B, but rather it will be given as a whole. So don't worry about that. Okay. So as examiner, we are told to mark it that way. So rest assured. Pop or the other one. Okay, so we're gonna find tension. So to find tension, I need to sub into one of them. Just simply sub into one of them. T equals 39.2 minus 4 times A. So if you put in a calculator, 39.2 minus 4 times 1.4, you get 33.6 Newton, and that's the answer. Right, that's part A and part B done. Part C. Given that A has traveled a distance of 2 meters, it strikes the ground. Find the speed of the A when it hits the ground. So part C, see that. So we're told displacement is 2. It's released from rest. We're going to find speed before it hits the ground. So question mark, A is 1.4. Okay, so here we go. So V equals, nope, V squared equals U squared plus 2AS. So V squared equals 0 squared plus 2 times 1.4 times S. So V equals square root of 5.6. So V equals to square root 5.6 is indeed 2.37 meter per second. We run to 3SF. Okay, right. Now, next example, we're looking into something a bit slightly harder. Okay, so let's have a look in here. Two particles, A and B, of masses 0.4 kilogram, 0.8 kilogram respectively, are connected by a light example string. Particle A lies on the rough horizontal table, 4.5 meters from a small smooth pulley, which is fixed at the edge of the table. So I'll draw a diagram in here if you're struggling with this question. Okay, so struggle to visualize it. So here's a pulley. Okay, this is particle A, and this is particle B. Okay, we're told that's 0.4 kilogram. So let's put it in there, 0.4 kilogram, and B is 0.8 kilogram. So what else have we been told? With the string taut, B hangs 0.5 meters above the ground. So we have a ground in here. Let's call it the ground. So I'm going to different color for the ground, just so that you know. The orange color means the distance. So a frictional force of magnitude 0.08 g opposes the motion of particle A. The system released from rest. Now, you can imagine when you release the system, what will happen? As B is heavier, you can imagine B will drop and A will move forward to the pulley, towards the pulley. Okay, so when particle A is moving towards the pulley, then the frictional force will be against the motion, which will be here. Right, so I'm going to use blue color for all the forces. So again, with tension pointing towards the pulley, okay, and then with forces from A, the weight 0.4 g, and reaction because it's on the table. For B, there's no reaction because B is dangling in the mid-air, so tension is the only force, and we've got a 0.8 g. Okay, so once you got all the forces, if you want to try question A and question B, feel free to be my guest. Pause the video and have a go. Okay, but if you just want to listen, you're welcome to do so as well. So particle A, okay? For particle A, we know the motion is moving to the right. So what we're going to do is we're going to use F equals ma to the right, okay? Because motion is going to the right. So the force will be T because we're going right. So the right force will be bigger than the left force. So will be the resultant force will be the right, take away the left. 0.08 g equals the mass 0.4 times A. 0.08 times 9.8 is 0.784. So t minus 0.784 equals 0.4a. So t equals 0.4a plus 0.784. For particle B, okay. Oh, so what about the reaction? We don't need a reaction for now. Now, reaction actually will become useful next year when we calculate friction, but for now we don't need it. Okay, so B, if you're really interested in the forces and friction, whatever, you can go to year two mechanics. I think it's chapter 5.3. Or if you want to look into how a full-fledged pulley question look like, you can look into year two mechanics, chapter 7.6. Those are the sort of the exam review exam questions. These ones, to be honest, these ones as well. So let's carry on. So B equals F equals ma, but you can see particle is going down. Okay, so the force is going down will be 0.8 g. The resulting force will be downward force. Take away upward force equals 0.8 a. So 0.8 times 9.8 is 7.84. So 7.84 minus t equals 0.8 a. Make t a subject again. So t equals 7.84 minus 0.8 a. Simultaneous equation, 0.4a plus 0.784 equals 7.84 minus 0.8a. Right? Make a subject, so bring minus 0.8 to the left hand side, becomes 1.2a. Brings 0.784 to the right, becomes minus. So that becomes 7.056 divided by 1.2. That gives you 5.88 meter per second square. It's actually moving quite fast. So, and then the question didn't ask for tension, but normally I do work out tension just, why not, simultaneous equation. So 0.4 times 5.88 plus 0.784. So, again, this is not really required by the question, but I thought it's just a good habit to work out everything in there. So 3.136 Newton. So anyway, the question only needs acceleration. We've done that. Part B, find the time taken for B to reach the ground. To find time taken with given distance. So Suvat. Okay, part B, Suvat. Displacement is 0.5 meters, right? And then we found out A is 5.88. We know system released from rest by time taken. So S equals UT plus a half AT squared. So S is 0.5, U is 0 plus a half times 5.88 times T squared. So, yeah, to get rid of the half in here, you can multiply left hand side by 2. So 1 equals 5.88 T squared. So T equals 1 over 5 divided by 5.88 square root. So square root of 1 over 5.88, which I get is 0.412 seconds. Okay, and that's the answer. Right, last but not least, question C. Now you can see the example, there's 2 stars next to it because of the difficulty of part C. Find the total distance traveled by A before it first comes to rest. This sub-question could worth up to 7 marks. I think usually 5 to 6 marks on its own. But anyway, nevertheless, it's a big question for part C. So what happens in here? Let me explain. All right. So what I'll do is first of all, let me explain this scenario here. Why is it worth so many marks? Now let me copy and paste this diagram. Okay. And I want to show you what happens. Okay, the subsequent motions of part C. Now I'll suggest you can draw a diagram but later, but I want you to listen first before you can draw a diagram. Now, can I actually rub off this part? Yes, I can. Rub off this part, I can. Rub off this part, I can. Okay, right. Now, I want you to think about, okay, so that's where A and B started, right? Now, what happened? I want to clean the diagram a little bit. Right, so when you think about, okay, what will happen, okay, the subsequent motions. Now, when the system is released, okay, B drops, A moves towards the pulley. Now, what happened then? B will hit the ground, right? B will hit the ground. And A would be here. So I'm going to call this motion 2, okay? Actually, we'll start with motion 1. That was the original, okay? So that's original. So motion 1 means at the original, at the starting position. Let's not use the word original. At the starting position. Okay. And then at 2, okay, at step 2, okay, B hits the ground. And what happened to A? Well, okay, A moves forward by 0.5 meters. Okay. String still taut. String is still taut. Okay. Now, but what will happen after motion 2? That's the tricky part. Now, will A stop in there directly? Will A stop in there in exactly, as B hits the ground, will A stop there immediately? Actually, it won't be. So A will be the third motion here. Third motion. Okay. A will jerk forward a little. String is loose. So there's no tension. So what I'm trying to do is, okay, if you don't know what I'm trying to draw, I'm trying to draw a tension, which is loose tension, loose string, and there's no tension in there. Okay. Now let me explain what happened. Why? Okay, think about this. Okay, think about on a just on a different diagram. Think about on the bus. Okay, on the bus. Okay, and this bus driver a bit reckless because he was looking at his phone, and this is you standing on the bus holding the handrail. Now, and then here's the traffic light. Okay, the bus driver sees the traffic light late. Now imagine this is position number 1. That's where we are. That's where we were. Okay, the bus driver sees it late. So we were here at motion 2. Actually, I need to put the bus a bit backwards. Okay. Now the bus driver sees the traffic light late. So what will happen then? Obviously the bus driver don't want to risk getting a ticket, so he will slam the brake. Okay, he will slam the brake. Now, as he slams the brake, what will happen to you? Well, what happened to not to you, sorry, to the bus? Does the bus stop there directly? Exactly? No, it doesn't. The bus will carry on forward a little bit until it stopped here. Hopefully, it will stop in time. Okay, obviously, you're not happy because it was harsh braking. Right, so that's 3. Okay, so that's what will happen in here. So the bus will jerk forward a little bit, or the braking distance until it stops. So what stops the bus? It stops the bus because of the friction and because of and the brakes. Right? So friction and brakes. But in this scenario, we don't have brakes. We just have friction stopping it. Okay? So that's sort of the scenario we're looking into here. So that's why the particle A will still move forward, jerk forward a little bit because of a spontaneity, because of a spontaneous motion of the particle. As it moves, as B hits the ground, A doesn't stop there. Okay, the string will bring the motion bring the motion forward, and A will continue to move a little bit forward before it stops. So, therefore, the question asks for total distance traveled by A before it comes to rest. So that's a total distance. So what we know is this is actually 0.5 meters because as B hits the ground, A will move forward by the same distance because the string was still in taut. Okay, however, and this is the distance we want to work out. So this is what I call a typical 3-part motion question, right? A 3-part motion question. So what do we have to do in here? First of all, we're going to set a sweep up from motion 1 to motion 2. Actually, let me use green. I was using green for motion 2. So from motion 1 to motion 2. Okay, we're going to set a sweep up. Okay, and then we're also going to set a sweep up on parallel from motion 2 to motion 3. Okay, so sweep up. Now, think about, okay, so let's flame the sweep up tables together. Okay, so obviously we want to find S is X in here, X meters. That's the X we want to find out. We know from motion 1 to motion 2, okay, particle A or particle B, doesn't matter which one because they're in sync. Particle A and particle B moves 0.5 meters forward. Initial velocity, we start from rest. Final velocity, is it 0? No, because even though B hits the ground, the speed of A, when we talk about final velocity, we don't talk about, the final where after it hits that point. We talk about the milliseconds just before it reaches that point. All right. So it's a speed at that point at motion 2, 0? No, because it's still moving, right? What we know is acceleration will work out as 5. Is it 5.8 or 1 point? Am I mistaken? 5.88. Yes, I remember right. Yep, 5.88. 5.88. Okay. Time we know is 0.41. Is that the same question? Sorry, I keep mixing up with the previous. Yes, no, it is the right question. 0.412. So what about motion 2 to 3? Now we know the final velocity will be 0, okay, because A will come to a stop, okay, because I'm going to use different color, not to use green, because green, you might suspect the green has anything to do with motion 2, but actually it doesn't, okay. A comes to stop, okay, right. A, acceleration. Is the acceleration same as 5.88? Should A be accelerating? Between motion 2 and 3, should A be accelerating or decelerating? Or the particle A, is it decelerating or accelerating? Particle A between motion 2 and 3 should be decelerating because it comes to stop, right? So it was moving forward from 1 to 2 because B was carrying, B was dropping, so therefore it brings forward A. But when B hits the ground, okay, A is no longer brought forward because of B. A was brought forward because what we call inertia is if you know this keyword, if you don't know this word, it's more like a physics word. You don't, not for maths. Inertia, it means there's an ongoing motion that make you jerk forward until it stops. It's like when a bus brakes very harshly, then you will suddenly, walk 2 steps forward. You don't stop there immediately because there's an ongoing motion bringing you forward, carry on with that motion. That's called inertia. Anyway, so so A is not accelerating, A is decelerating. So therefore, what we need is we know A is a deceleration. So therefore, we need not new, but different value of A. We need a different value. Okay. And what else do we know? Well, the question is, how do we connect these two Suvat tables together? You can see that the connection is the motion 2. And between motion 2, we can connect the final velocity to the initial velocity. They're equal. Because the final velocity from motion 1 to 2 is the beginning motion, is the beginning velocity, is the initial velocity from motion 2 to 3. So our first step is to work out the final velocity from motion 1 to 2 and help us to put it into the initial velocity as motion 2 to 3. Okay, so let's do that. All right. So I'm going to put in also, so that's the first thing we'll do. So V equal, okay, so in this step, V equals, I can use U plus AT. So 0, not 0, so V equals to U, which is 0 plus A 5.88 times 0.412. So 5.88 times 0.412, I get 2.42256. So V equals to 2.42256. So if V equals 2.42256, I'm using different color in here. 2.42256. 2.42256. So that becomes 2.42256. That's a U. Okay, so you try use different color, to show you the connection between numbers. Right, so we need 3 pieces of information to work out the displacement in Suva. We've got we've got U, we've got V, but we don't have A. So as said, we need a deceleration. We need to find new value. So let's do that together. So this is after motion 2. After motion 2. So what will happen to particle A? So this particle A. Okay, this is A, which is 0.4 kilogram. Now, after motion 2, there's no more tension. So what stops A? The friction. Friction stops A. Okay, so you can write in here. Okay, so A comes to stop because of friction. So let's use F equals ma. Now, which way is the particle moving? Particle is still moving to the right. Okay. So therefore, what it means is the resultant force will be negative 0.08 g. It's negative because the force is pointing to the left against the motion. Equals the mass 0.4 times acceleration. So if you divide it by 0.4, so negative 0.08 times 9.8 divided by 0.4, so A equals to negative, let me write now. You should get a negative 1.96, which makes perfect sense because A is decelerating. Remember, so A is negative 1.96. So after we find out A equals negative 1.96, we can then work out the displacement. So S. So S equals, what can we do actually? I want to use the V squared equals U squared plus 2AS. So V squared is unknown. Sorry, we do know V is 0. So 0 squared equals U squared 2.42256 squared plus 2 times negative 1.96 times S. So we can do the 2.42256 squared. So 0 equals to 5.86879 minus 3.92s. Bring the negative to the left-hand side, becomes positive 5.86879 divided by 3.92. That gives me 1.5 meters. So therefore, the total distance A has traveled equals 0.5 meters, which is the initial motion from motion 1 to 2, plus the distance traveled after B hits the ground, which is 2 meters. So 1.5, which is altogether 2 meters. Now you can see why this question carries a lot of marks. I'll explain again. Okay, for part C. Now this question is quite sort of, I won't say it's extremely common, but when you see a 5 or 6 marker dangling at the last part of the question, of a pulley question, you know it's usually about this. Okay, what I call 3-part motion. So to do this, what you need to do is you need to set up a motion 1, set up a 2 CVAR from motion 1 to motion 2, from motion 2 to motion 3. Now, by the way, you will see this again in year 2 mechanics. Okay, so anyway, so motion 1 to motion 2. So we set up a CVAR. Okay, we know S is 0.5, U is 0 because I'm from rest, A is 5.8 because we calculated in previous part, and so as time. And what we need to do is we first have to work out the final velocity from motion 1 to 2. That makes it into the initial velocity from 2 to 3. Okay. This question wants to find the total distance, so S is X. They could ask for T, okay, but this time they ask for X. S. And then V is 0 because it's in a million second after when we talk about A finally comes to rest, it will stop ultimately. So V is 0. And A, we need a new value of A because deceleration. So I draw another motion, another diagram, another demonstration of particle A after motion 2, which is there's no more string. The tension is no more tension because the string is loose. So what's stopping A is just the friction. So F equals ma going to the right because particle A is moving to the right. So it's negative 0.08 g equals the mass 0.4 times A. And once you've with the new value of A that you can use as CVAR, you work out S. And read the question again. The question wants to find the total distance traveled by A before it comes to rest. So we started here, motion 1, all the way 0.5 to motion 2, and then 1.5 to motion 3. So altogether is 2 meters. All right. So take the time to write the notes that you need to step by step. Okay. Why do we need the new value of A, etc. You know, try to write as many little notes to yourself, explaining to yourself what have you done. If you can summarize them into steps as well, that will be even better. The reason being is when you read this question again, I'm pretty sure you will, you want to look at your notes and explain to yourself, okay, why do I do this? Why do I do this? What's happening in here? Okay. Now, once you're happy with this, okay, the final question, okay, for this chapter 10 is a very similar question. I just want to make sure you can do something similar. Okay. So I'll let you read the question. Okay. So what I want you to do is have a go at question A, B, and C first. Have a go at question A, B, and C. Okay. Pause the video, have a go. When you're ready for the answer for A, B, and C, you can press play. So here are the final answers for question A, B, and C. Okay. Actually, I do want to let me give you the answer for part D as well, 1.23. So in case you've done that already. Okay. If you're struggling with part A, okay, I'll give you a bit of a hint. Suvat. Okay, pause video. Think about Suvat again. You're given some information about 0.98 and 0.9 meters, 0.8 seconds. So do Suvat, try work out A. Okay, so pause video again if you're struggling with it. But otherwise, I'm going to show you the full working out now. I'm just showing you working out for question A and B and C. Okay, question A, Suvat, as I said. So S equals 0.9 and U is 0. A is unknown, T is 0.8. So you can use the Suvat and you work out A equals 2.8125. Once you've done that, you can then set up the equation for particle A and particle B. For particle A, we know the motion is going to the right. So we set up F equals ma to the right. And then because motion is going to the right, so therefore the resultant force will be motion to the right, forces to the right, tension, take away force to the left, friction. So T minus F, right, take away left, equals M, 0.8 times the acceleration you've found out. And then you've multiplied these two numbers, you get 2.25. You realize there are two unknowns, so I stop there. Next, I move on to motion particle B. So F equals ma going to down because particles B will be dropping. So resultant force will be downward force, take away upward force. 1.2 G minus T equals 1.2 times A. And then you put in the calculator 1.2 G and put the right side in the calculator, you get this. And suddenly you found out actually it's not a simultaneous equation. You have to work out T is 8.385. Then we know T is 8.385, and that helps us to work out friction consequently. And you can work out friction equals 8.385 minus 2.25, which is 6.135. All right, so hopefully it doesn't cost you too much of a trouble. The main skill you need to learn in here is using Suvat, but also setting up a equation for particle A and particle B separately. Depends on the motion. Okay, if it's going to right, then use F equals ma to right. If it's going down, use F equals ma to down. But previously also you've learned if particle, is going, particle for this one, because Q is heavier, it's going down, so you can set up F equals ma upwards and downwards for P and Q respectively, and then do the same thing. So it depends on, therefore, the motion. The direction of motion is very important because it guides you what kind of F equals ma you want to calculate. Okay, right, now part D. All right, so as I said, what I need you to do is like a previous one. Okay, try set up a Suvat from motion 1 to 2, and then Suvat from motion 2 to 3. So let you try that first. So what I want you to do is I would like you to set up the Suvat, okay, from motion 1 to 2 and motion 2 to 3. Okay, so pause the video and set up the Suvat. So a little diagram to show you. Okay, this is how you should be setting up. Okay, fill in table. Right, so this is how you should be setting up a Suvat table. Okay, the Suvat tables for this what we call three-part motion, because given that A does not reach the pulley and the frictional force remains throughout, find total distance by A. When B hits the ground, we know A still move forward a little bit, okay, because of the inertia. So what you want to do is, okay, I'll let you pause video. Okay, so this is Suvat table if you didn't get it right. Okay, but here you go. Okay, see if you can follow the previous example and try to have a go at this question. Pause the video, okay, have a go at the question with these two Suvat tables. Want to work out S in here for now, and then the final answer. When you're ready for the answer, you can press play. So here are the final answers. So first of all, work out V equals 2.25, and we know the connection between the first Suvat table to the second one is through the V to the U, so V equals 2.25, which is the new U value. And then we also need to find a new value of A, which I've drawn a new diagram. So we know there's no tension, so the friction is the only force stopping A moving forward. So when we do F equals ma to right, friction is pointing to left, so therefore friction will be negative. So negative F equals 0.8A, and then divide by 0.8, you get A equals, either you want to use the fraction or the decimal versions, feel free. Friction seems to be easier for now, but I've used decimal in here, doesn't matter. So, and then to work out displacement, I can do V squared equals U squared plus 2AS, plug in the U, plug in the A, carefully manipulating the answer, putting the calculator carefully. By the way, just one thing, your S and your 5, and a lot of students will have a really bad handwriting. And as a kid, I always mix up my 5 and 3 and the S. So be careful with that. It looks like a 5, but actually it's an S. Bring it over left hand side. So actually, you know what I will do is, let me change into an S. Use a different color just to illustrate. Okay, so that's an S. Okay, so S equal. Yeah, and S equals 0.33 you've calculated, so the total distance will be 1.23 meters. All right. Now, normal question does not include the last part, but I thought I should be liable, I should be responsible to teaching you the tricky part as well. Okay, a normal question, exam question will look like these ones. A simple ones will look like these ones. Okay, and that's the end of chapter 10.